Good afternoon to one and all. I welcome you all for the today's session for the energy engineering. In that, I will be discussing about module two. That is part mod in module two. That is part two, hydroelectrical electric energy. Okay, so hydroelectric energy. I will be discussing about hydroelectric energy. Before starting the hydroelectric energy, we'll better go to the syllabus, what it contains. Okay. Huh? So hydroelectric energy, in that it contains hydrographs, flow duration, and mass curves, unit hydrograph, and numerical storage and pond age. Okay, pumped storage plants. Okay, low and medium high head plants, penstock, water hammer, surge tanks, gates and walls. General layout of hydel power plants. Okay, we will go ahead with hydrological. Before discussing about hydrological cycle, we'll be discussing what is hydroelectrical electric energy. Okay, hydroelectric energy, that hydropower plays a very important role in the development of the country as it provides power at cheaper rate being perpetual sources of energy. Okay, nearly 20% of total world power is generated using hydro plants. There are 90% of nations power is met with hydropower. As per the estimate of World Power Organization, the hydro potential is roughly 5,000 gigawatts, whereas only 200 gigawatts is presently developed. Okay. How much it is developed? Only 200 gigawatts is presently developed. Okay. In 1897, the first developed hydro station with capacity of 200 kilowatt was installed at Darjeeling. In 1902 at Shivasamudram for 4,500 kilowatt, and in 1914 hydro plant of 1550 kilowatt was installed at Gokak Falls. Hydrological cycle, it is essentially to study and measure the quantity of rainfall and water flow available to the established a hydroelectric plant. Okay, so what is hydrological cycle? It is very essential to study and measure the which is helpful to measure the quantity of the rainfall and water flow available to establish a hydroelectric plant. Okay, so hydrology, the science which deals with rainfall and runoff, is known as hydrology. Evaporation of water from the surface of rivers and oceans and its precipitation over on the earth is known as hydrological cycle. Okay, water is evaporated from plants, rivers, oceans and carried with air in the form of vaporization, which is known as clouds. Which is known as clouds. The hydrological cycle involves the following processes. What all it contains? You all can see here: evaporation, precipitation, infiltration, percolation, transmission. Okay, all this it contains. Okay, and ocean. We will be discussing one after the other. First of all, we will take evaporation. This is the major means of depletion of water from the earth's surface into atmosphere. Water sources on earth's surface is converted into vapor by solar energy. High temperature, low humidity and high rate of wind flow are major factors that assist in water vaporization process. Next we will be discussing about this transpiration. Okay, it is the process of water evaporation by the plants. At all plantation and vegetation on earth absorbs water, you all know, through their roots and release it through their leaves to atmosphere in the form of vapor. And next we'll be discussing about seepage. Seepage. What is seepage? Seepage is also known as infiltration. Seepage is also known as infiltration. Okay. It is the process of water entering into the ground. Water on the earth's surface percolates through the soil and forces the groundwater under the earth's crust. Okay. And next we'll be discussing about runoff. It is the remaining part of the precipitation water after evaporation, seepage and transpiration available on the earth's surface. Depending upon the altitude at which it is available, it possesses the potential energy and starts flowing towards the lower levels through the stream and rivers in such a way that the runoff from large area flows into the reservoir. Part of the land from where the runoff flows into the reservoir is called as catchment area. Okay, what it called? Catchment area. Also, part of land from where the water starts flowing is known as upstream, and while lower portion of the reservoir which receives water, it is known as downstream. Okay, did you all get this? What is hydrological cycle? Next we'll be discussing about hydroelectric power plants. A hydroelectric power plants is one in which hydraulic energy of water is converted into electrical energy using hydraulic turbines. Okay. While selecting the site for hydroelectric plants, we need all these below points, that is availability of water. Okay, this while selecting site for hydroelectric plants, we need availability of water. The site selected should be such that requisite quantity of water being available throughout the year of economical generation of power. To estimate the availability of water, geographical investigation of the site is to be carried out. Okay, previous records of rainfall of the particular area are to be studied. Next will be second one is storage of water. The site selected should have good storage capacity, sufficient enough to use for full year. This depends upon the reservoir capacity and catchment area. Okay, as of we have discussed what is catch-off area, you all know. It is always intended to store water enough to use, okay, enough to use even during dry periods to the extent possible. Third one, that is head of water. Head of water is the highest level of the water at the upstream from where water flows down for the power generation. Okay, higher the head available, lesser the quantity of water required for a known power output, and hence lesser is the storage requirement. Okay, you all got this point. Fourth one, distance from the load center. It is always essential that the site selected should be as nearer as possible to the load center. Increased distance lead to increased power transmission cost and higher transmission losses. So we need this load center as much as nearer, okay, to the power station. That is equal to G is equal to Q into H into nu into T. The electrical energy produced in kilowatt can be written in the form of W, that is equal to 1000 into 9.8 1 into Q into H into nu into T, that is equal to 9.81 into Q into H into nu into T kilowatt hour, where nu is the efficiency of the turbine generator assembly and T is the time in hours. Okay. Next we will be discussing about classification of hydroelectric power plants. Hydroelectric stations may be classified as follows. First one, according to the quantity of the water available. In that, under that what comes? Runoff river plant with pondage. Runoff river plant without pondage. Pumped storage plants. And second one, that is according to the availability of head. Under that what comes? High head power plants, medium head power plants, and low head power plants. And third one, according to the nature of load supplied, that is base load plants, peak load plants. These are the two load plants. Okay. And capacity of the plant, and that low capacity plant up to 1 megawatt, and medium capacity plant 1 megawatt to 10 megawatt, and high capacity